So, good morning, everyone. I already introduced the project, so I'm going to go directly to my part of the presentation. So, as Freya said, iFishIENCi is a project that brings together 16 partners. And the role of AquaBioTech was to demonstrate, one part of the role of AquaBioTech was to demonstrate the technology developed in iFishIENCi. Specifically today, I'm going to talk about a salmon case study in Malta. Of course, for most of you, the fact that we are farming salmon in Malta is a bit strange as a Mediterranean country, but we're going to have them until the next month, so it should be fine about the temperature. Anyway, so let's start. So first of all, I would like to give you a brief introduction about our system. As Freya said, we have a SmartRAS system. What is exactly a SmartRAS system? We are still learning about that. What I can tell you is that the system that we've been using for this demonstration is a RAS system. Is equipped with 12 fiberglass tank of 650 liters. That you can also fill it up until 1.3 cubic meter, so you can use for different purpose. The system is also equipped with some camera that you can use to record fish behavior, and this one was one of the objective of the project. So you can see here above the tank we have some camera. As a RAS system, you have all the environmental parameter controlled. As you can see here in the picture, we have the reservoir of water, or as we call SAMP, where we have some probe where you can record data such as dissolved oxygen, redox potential, temperature, and pH that are continuously pushing to the Oxygat Pacific system. That is pushing the data to the iBoss. The iBoss technology is going to be presented by Luke later on. So, as soon as the water is back to the reservoir, it's pumped through a UV and ozone treatment, just to be clean and disinfected, and then back into the tank. Before going back to the reservoir, the water is filtered by a mechanical filtration with a drum filter. So the wastewater is disposed, and this one was one of the demonstration of the project. So the reuse of the sludge coming from the system, while the clean water is pumped back into the system. So what's the advance of this technology? First of all, we were trying to demonstrate the let's say assessment of the fish behavior during feeding, specifically using either hand feeding or automatic feeding, and recording with camera. So the experiment was split in two different phases: a preliminary test. So the location is exactly the same, base 0, habitat in Northern Malta. Some of you are already part of the department, so you know what I'm talking about. The target species, as I said, was Atlantic salmon, 400 fish per tank, starting weight 13.5 grams. Number of tanks were 2. Usually when you perform an experiment, you have replicates just to give statistical significance to your experiment. But in this case, it was just to demonstrate two different technology, hand feeding and automatic feeding. So the duration of the trial was 8 weeks. Feeding strategy, there were two different: one tank and fed, one tank automatic fed. Feeding method, apparent satiation 4 times a day. So fish were fed at 9, 11:30, 2, and 4 p.m. Fish of tank 3, so where the automatic feeding was delivered, were recording 15 minutes before and after each feeding event to evaluate the behavior. Light regime, temperature, and bulk weight are, let's say, the usual one that we can use for salmon. So 13 plus minus 1 degree, 12 hours dark and 12 hours light, and bulk weight weekly, just to record the growth of the fish. So the feed was a commercial diet, start element 2 millimeter from Altec Open, that is our supplier. Here you can see the composition. So at this stage, fish need more protein than fat. So we have 54% of protein and 15% of fat. And the target of this demonstration, this preliminary test of the demonstration, was the calibration of the algorithm to detect fish and Nicholas is going to present you the result, and also monitoring of fish behavior and comparison between two feeding strategies. As you can see from the graph, about the growth of the fish, the trial lasted for 63 days, and we have a slightly higher growth in the automatic feeding. In this case, we cannot see that the fish are growing better because we are analyzing just the growth of the fish. We are not analyzing any performance indexes. So this is part of the demonstration that will be, the result will be presented later. So during the main trial, the setup of the bay was exactly the same. Same tank, same fish. So fish end up the first phase at 43 grams. Then they start the new phase. Same number of tank. In this case, the duration was 3 weeks. Feeding strategy, exactly the same as the first experiment, tank 2 unfeeding, tank 3 automatic feeding. The only difference was the feeding method. So instead of apparent satiation, in this case, we were testing 3 different fixed rates. The first one was from commercial guidelines from our supplier, so 1.5% in body mass. During the second week, we were testing half of the ratio, and during the third week, double of the original ratio. Why? Exactly because we would like to see difference in feeding behavior. So our goal is to push during the second week the fish at maximum activity, because if we're feeding less fish, it means that they were more active. During the third week, they were satiated, so the activity was less. In this case, Nicholas could use a scoring system from 0 to 2, that is going to present later, to understand how much was the activity of the fish during these 3 weeks. So in this case, light regime, temperature, and bulk weight were performed as before. The only difference was the feed. So in this case, the commercial diet was changed, because in this case, we were using crystal 2 and 3 millimeter from Altec Open. The difference is that because usually when the fish are going to a different, let's say, stage of their life cycle, you change the nutritional requirements change. So in this case, as you can see from the composition, the protein content is lower than the diet that we were using before. So it's 41–44%, but in this case, they need more fat. So this one is a grow out diet that they use to feed fish until the commercial size. Of course, you change size of the diet based on the size of the fish. In this case, the key performance indicator of this trial were fish behavior algorithm can evaluate fish activity at different feeding regimes using a scoring system 0 to 2 that we will present later by Nicholas. Feed behavior algorithm can evaluate different feeding regimes using behavior of Atlantic salmon. And this one, it was I told you before, so trying to understand if a different feeding rate can affect the behavior of the fish during the feeding event. And lastly, the smart feeders can be regulated through IVOS. So our final goal was to, and this is the trial that is we are carrying now, is to understand if this data can be used to automatically set up our automatic feeder based on what the fish need and not based on what you think the fish needs. Lastly, FishMET can predict body mass based on feed intake and temperature. This one will be presented by Serbia. So as Freya said, there's going to be a virtual tour, that is this one, some video from Bay Zero, and in-person tour that I'm going to give you downstairs. Some of you are already part of Innovia, so you've been in Bay Zero many times, some I don't know, so it will be interesting to see what we are doing downstairs. So first of all, I want to show you how we can see the fish inside the tank with a camera. So this one was the starting of the preliminary part of the trial. So all the fish are swimming against the current. As a salmon, they usually swim against current. And as you can see here, there are like 400 fish in the tank, size of around 20 grams. These other two videos are just to show you the different type of feeding that we are providing to our fish. So the top right is automatic feeding, performed 4 times a day, percentage of 1.5% during the day, while the bottom right is hand feeding. As you can see, there is the peculiar behavior of the fish during the feeding. So they are coming to the surface because in this case it's a sinking feed. So whenever you leave the feed in the water, it's going to the bottom. As a salmon, they don't eat on the bottom, but they just eat during on the water column. So whenever the feed touch the bottom, they are not eating anymore. So just to avoid in RAS pollution of the water, you have to be careful when you feed the fish. Try to not leave any uneaten pellet on the bottom. In the case of the automatic feed, of course, it's a bit more complicated because as an automatic system, you have to check after each feeding if there is any uneaten pellet and remove accordingly. So, just one more. So what's next? First, we're gonna analyze the data on the feeding behavior. We are gonna evaluate the fish appetite based on fish movement and real-time activation of the automatic feeding. We want to optimize the feeding by reducing waste, and our final goal, but this one will be probably after the end of the project, it will be the reduction of manpower and labor costs. So thanks for your attention, and I'm gonna give now the floor to the other partners.